Hi guys, let us discuss matrix chain multiplication using dynamic programming. We all know a matrix size is given by number of rows and number of columns. Here, two matrices of size m into n, that means m rows, n columns, and n into p, that means n rows and p columns are multiplied. For a matrix multiplication, the rule is the column size of the first matrix should be equal to the row size of the second matrix. So when you multiply these two matrices, the resultant matrix size will be m into p, and the number of multiplication involved in this multiplication is m into n into p. So in this problem, we are not going to actually multiply the matrices, but we want to find the way to minimize the total number of multiplication involved in multiplying more than two matrices. For example, here you assume four matrices A, B, C, D. So I want to multiply these four matrices A, B, C, D. So I can parenthesize in different ways as shown in the diagram. But we should note down that matrix multiplication has got associative property. That means if you parenthesize in any order, the multiplication will give the same result. So that means suppose if you see the first option, you multiply B and C first, then multiply the result of B and C with A, and the result of the total multiplication again multiplied with D. Suppose if you take the second choice, here you multiply B and C first, then the resultant matrix is multiplied with the D, and finally you multiply with the A. So here you multiply C and D first, then you multiply with B, then you multiply with A. Like that, if you see this option, multiply A and B and C and D separately. Finally, you multiply the resultant of these two multiplications. Like that, I can parenthesize in any one of these options, but the ultimate aim is in which parenthesization choice I may get the lesser number of multiplications to get the result. The important point here is this A, B, C, D order should not be changed. That is, matrix multiplication has got associative property, but it doesn't have commutative property. That means A into B is not equal to B into A. So this A, B, C, D sequence should always be maintained in the same way, but we can parenthesize in different methods as shown in the diagram to minimize the number of multiplications. Matrix chain multiplication problem statement. Before discussing the problem statement, let us see how the matrix size format are given in the problem. So here if you see four values are given 2, 4, 3, 6. We should assume the first matrix of size 2 by 4, second matrix of size 4 by 3, third matrix of size 3 by 6, because as per the matrix multiplication rule, the column size of the first matrix must be equal to the row size of the second matrix. So when four values are given, we can have to take the size of three matrix as given in this example. So once you understand this example, then we can see the problem here. Given a sequence of n matrices A1, A2 and so on An, the dimensions are given a sequence of values like this P0, P1 and so on Pn, where I is equal to 1 to n. If we take the matrix AI, it has dimension Pi minus 1 into Pi. That means let us understand very easily. Suppose if you take the second matrix, what is the size we assumed? 4 by 3. So if you take the third matrix, what is the size we assumed? 3 by 6. That is what given here. So finally, the ultimate aim is determine the order of multiplication that minimizes the total number of multiplications. Refer the input array. It contains 5 values 5, 10, 15, 20, 25. As there are 5 values, the number of matrices will be 4 and the order will be 5 into 10, 10 into 15, 15 into 20, 20 into 25. You construct a table like this with 4 rows and 4 columns because 4 matrices are there. So you construct a table like this with 4 rows and 4 columns, and the columns and rows are labeled as 1, 2, 3, 4 as shown in the diagram. Now we have to fill this table using this formula. So this formula is going to be used throughout this calculation. So what is the first value? C of ij is equal to 0 if I is equal to j. So with this rule, so we are filling 1 1, 2 2, 3 3, 4 4 as 0. So that is what shown here. So now we have to fill the upper diagonal values using this formula. What about this lower diagonal? So this lower diagonal will be empty. The reason is the matrix multiplication, we can go only in the sequence. A, B, C, D means we can go only in that A, B, C, D order. So we cannot go in reverse. So there is no value for the table entries 2 to 1, like 3 to 1, 3 to 2, like this. So this lower diagonal will be empty throughout this calculation. So we are going to fill this upper diagonal using this formula. Now we are going to fill this place C of 1 comma 2. That means I value 1, j value 2. So this place has to be filled. So you refer the formula. So I value is 1. This k value is equal to I initially, and it goes up to 1 value lesser than j. So here what is I value? 1. J value 2. So k value will start with the I value, that is I is equal to 1, k is equal to 1. But when you increment the k value one more time, it will become 2. But k value, you refer the formula, it goes up to only one value lesser than j. That means less than j. It is not less than or equal to j. Carefully you observe here. So with these values, we are going to substitute in this formula. So C of 1 comma 2. So I is equal to 1, k is equal to 1, j is equal to 2. So you C of I comma k, that is C of 1 comma 1 plus C of k plus 1 comma j. K value 1, so C of 2 comma 2 plus this di minus 1, dk and dj. So these values are referred as d0, d1, d2, d3, d4. So what is the value of d0? Because di minus 1 means 1 minus 1 0. So d0 value is 5. D1 is 10, D2 is 15. So you multiply all these values, you will get 750. So the 750 is stored in this place. So C of 1 comma 2 is equal to 750. Next, we are going to fill this entry 2 comma 3. Okay. So you may have a doubt why I am moving in this diagonal, because we have to move only in this diagonal direction. The reason is these diagonal values are going to be reused in the next diagonal process. So we have to go only by this approach. So C of 2 comma 3, that means I is equal to 2, k is equal to 2, because k always starts with the I value, and j is equal to 3. So the k value will take only 2, because when you increment one more, it will become 3, but we have to go only up to less than j value. So that is why I is equal to 2, k is equal to 2, j is equal to 3. So you substitute in this formula. So C of 2 comma 3 is equal to C of I comma k. So you substitute I is equal to 2, k is equal to 2. So C of 2 comma 2 plus C of k plus 1, that is 3, comma j value 3 plus d I minus 1, I value 2, so d1 is 10, d2 is 15, D3 is 20. So you multiply these values, so it will become 3000. So the 3000 will be stored in this place, that is C of 2 comma 3 is equal to 3000. Now we are going to fill this entry, that is 3 comma 4. So C of 3 comma 4, I is equal to 3, J is equal to 4. So K starts with the I value, so K is equal to 3. So here also K can take only one value, 3. So you substitute in this formula as we have done earlier. So I value 3, so C of 3 comma K value also 3, 3 comma 3 plus C of K plus 1, that is 4, J value 4 plus di minus 1. So 3 minus 1, 2. So d2, d3, d4. So d2 value is 15, d3 is 20, d4 is 25. So you multiply all these values, you are getting 7500. So 7500 will be stored in this place, that is C of 3 comma 4 is equal to 7500. Now we have to fill this entry 1 comma 3. So I value 1, J value 3. So now you listen here, I is equal to 1, J is equal to 3, K value starts with the I value, that is I is equal to 1, K is equal to 1. Next time I is equal to 1, J is equal to 3. I, J values will not change, but K value will be incremented once, it will take 2, because we already seen that K value will start with I and it will go up to one value less than J. So in the last three calculations, we had only one final value, but here only this minimum will have meaning in this calculation, because in the last three calculations there was no meaning for this word minimum because there was only one value. But here we are going to have two calculated values. Out of this we have to take only the minimum one. So first we have to do the calculation with I is equal to 1, K is equal to 1, J is equal to 3, as we have done it in the earlier calculation. Next we have to do the calculation with I is equal to 1, K is equal to 2, J is equal to 3, and out of these two values we have to consider only the minimum one. So you see, first you apply with I is equal to 1, K is equal to 1, J is equal to 3. So C of 1 1 plus C of 2 3, because K value 1, K plus 1 will become 2, J value 3, plus di minus 1, d0, and dk value is d1, dj will become d3. So that means d0 is 5, d1 is 10, d3 is 20. So you multiply that, 20 into 5, 100, 100 into 10, 1000. That is what you have substituted here, 1000. And C of 2 comma 3 we have already calculated. So that's what I told you. These diagonal values will be reused in the next calculation. So you substitute 3000 here. So this is one calculation. The next calculation, I is equal to 1, K is equal to 2, J is equal to 3. You do the same way. C of 1 comma 2 plus C of 3 comma 3 plus D0, D2 and D3. What is the value of C of 1 comma 2? 750. It is substituted here. C of 3 comma 3 is 0. The D0 value is, we know, 5, and D2 is 15, D3 is 20. So again 20 into 500, 15 into 100, 1500. So 1500 plus 750, you will get 2250. So there are two values now. The first value is 4000. The second value is 2250. So out of this, I will take the minimum 2250. That value is filled in this entry C of 1 comma 3. Now we are going to fill this next diagonal entry 2 comma 4. So I is equal to 2, J is equal to 4. So I value 2, so K value will also start with 2 and J value 4. Next time I is equal to 2, J is equal to 4, but K will be incremented by one value 3. So as we have done it in the previous calculation, we have to calculate two values here. the first calculation is C of I value 2, k value 2. So C of 2 comma 2 plus C of k plus 1 is 3. So 3 comma j value 4, 3 comma 4 plus d I minus 1, that is 2 minus 1 d1, dk means d2, dj means d4. So 2 comma 2 0, we already know. 3 comma 4 we already calculated, isn't it or not? So 3 comma 4 is 7500 plus d1 is 10, d2 is 15 and d4 is 25. So you multiply 10 into 15 into 25, you will get 3750. Next calculation is I is equal to 2, k is equal to 3, j is equal to 4. So C of I value 2, k value 3. So C of 2 comma 3, k plus 1 is 4, j value 4. So C of 4 comma 4 plus d I minus 1. So 2 minus 1, 1. So d1, dk value is d3, j value is 4. So d4. So C of 2 comma 3, we refer the table. So 2 comma 3 is 3000 plus 4 comma 4 is 0 plus d1 is 10, d3 is 20, d4 is 25. So you multiply 10 into 20 into 25, you will get 5000. So out of these two, the first value will be 11,250, the second value will be 8000. So we have to take only the minimum value 8000. Finally, we have to fill this entry 1 comma 4. I is equal to 1, j is equal to 4. K value will start with the I value, that is I is equal to 1, k also 1, and k will be incremented by 1, that is k is equal to 2 and k is equal to 3. So now we have to calculate 3 values, and out of these 3 values we have to consider the minimum. So first one, I is equal to 1, k is equal to 1, j is equal to 4. So you apply in this formula C of 1 1, C of 1 1 is 0, C of 2 comma 4. So 2 comma 4 we already calculated 8000, that is what we have substituted here, and d0, d1, d4. d0 is 5, d1 is 10, d4 is 25. You multiply all these values, you will get 1250. The next value is I is equal to 1, k is equal to 2, j is equal to 4. So here C of 1 comma 2. So 1 comma 2 we already calculated 750 plus C of 3 comma 4. 3 comma 4 is already available 7500 plus d0, d2 and d4. So you will get 5 into 15 into 25. You will get 1875. Next I is equal to 1, k is equal to 3, j is equal to 4. So C of 1 comma 3, 1 comma 3, the value is 2250, it is available, and C of 4 comma 4 is 0, and d0, d3, d4. d0 is 5, d3 is 20, and multiplied by 25, you will get 2500. So there are 3 values here. Out of these 3 values, the minimum value is 4750. So you fill this entry with 4750. So now the table is completely calculated. So now what we have to do, so we have to consider only the last column. You see which one is the minimum. So 4750 is the minimum one. So what we have to do, so the 4750, where you got it, that is I got it here, that is when you got this value, when I is equal to 1, k is equal to 3, isn't it or not? So that means you have to parenthesize first 1 2 3, that is the first step. So A B C is parenthesized now. So now what you have to do, you have to go and refer C of 1 comma 3. Okay, because this 4750 you got it here when I is equal to 1, k is equal to 3. When you refer C of 1 comma 3, we got the minimum value 2250 when I is equal to 1, k is equal to 2. So by having this I is equal to 1 and k is equal to 2, we are going to parenthesize the first two matrices A and B. So the next parenthesization is done for A and B. Finally, if you refer C of 1 comma 2, we got this value when I is equal to 1, k is equal to 1. That means we can have only one matrix inside the parenthesis. So that is why we stop the process, and this is the final answer. In this case, to minimize the total number of multiplications, we should multiply A matrix and B matrix first. The result of the multiplication of A and B is to be multiplied with C. Then the total result is to be multiplied with D to minimize the number of multiplications.